I'm Mary D. Ojala, Conference Program Director, and I'll be the moderator for this session, which is all about database as a service comes to the enterprise. And our speaker for the session is Paul Bartak, who is the distinguished engineer with Rocket Software. If you have questions for Paul during the session, do put those into the chat function. And after, excuse me, after the session, we will go over to the networking area to continue the conversations. So now let me turn the session over to Paul.
Good day, everyone, and welcome to this session on DB2 participating in the DevOps world. More specifically, how enterprise data sources can participate in the DevOps world. My name is Paul Bartak with Rocket Software. If we were face-to-face, I would likely want to know more about several items in your shop. For example, to learn more about the fast release cycle in your enterprise. How are you gaining a competitive advantage against the competition in your own industry through the rapid and quality delivery of IT features into production? Are there differences between the culture, the process, and the tooling between your Z enterprise servers and non-Z or distributed platforms? Basically, to gain a better understanding of where Z, and specifically DB2 fit into the innovation delivery for your enterprise. Truth be told, I represent a specific product that delivers database as a service for DB2 and soon other Z resources. But this is not a product presentation. Therefore, I'll be focusing on the importance of addressing database as a service, with DB2 being the primary example, and the attributes of database as a service for your consideration as you consider your options. The intent of this presentation is to cover the key aspects of making an enterprise data server like DB2 a first-class citizen in your DevOps processes. DevOps is not a product, and it's certainly not a single product. Rather, it's an ecosystem of solutions that work together to enable continuous integration and continuous delivery. It enables agile and lean development practices with quality. In a nutshell, once your enterprise and team have bought into the competitive advantages obtained by the rapid quality delivery of innovative features to your customers, tooling helps to manage the volume, the variety, and the velocity of change that's common in this practice, essentially putting efficiency into practice. DevOps is a large topic and it encompasses many areas. The focus of this presentation is how to bring an enterprise data source like DB2 and others into your organization's DevOps processes. The developer is a key role, focused on the rapid delivery of new application features. When a data source like DB2 is involved, what are some of the key considerations to elevate the developer while at the same time liberating the administrator? Elevating the developer, in other words, is making DB2 operations happen at the speed of the developer. A primary lean tenet is that where there's a handoff, there is potential for inefficiency. There's a queue where work can gather, even if it's briefly, and there's a context switch, and there'll be more thought on this throughout the presentation. Liberating the administrator is chartered with maintaining the quality of the enterprise data. They have the knowledge and the stewardship of this administration, and this all needs to be honored, and the tooling should come alongside them and really complement them, allow them to perform higher level value tasks for your enterprise. We can speed up DB2 operations through several practices, through several approaches. Just to introduce some of the ideas now, offering database as a service, microservices that enable automation in your shop that you might be able to purchase or perhaps even develop on your own. Expand infrastructure as code to data sources. Codifying important rules, enterprise rules around your data, thresholds and limits. Creating guide rails for the developer and monitoring for all that are involved. This results in efficiency and continued platform relevance. It is summarized by faster response for your lines of business, directives that honor your IT and administrative standards and controls, all while minimizing wait time for developers so that we can really fuel the innovation engine. The next few slides will cover 4 key tenets in the area of delivering database as a service into your DevOps fast release cycle. The first 2 here are grouped together on this slide, and they're very focused on the developer, on elevating the developer, on-demand and self-service operations. The picture on the right, I call it the inner loop and the outer loop, is just a simple depiction of some of the cycles a developer may need. Perhaps some database objects and or data is just needed for testing purposes, and I refer to that as the tighter inner loop. Tooling can help to quickly, on-demand, self-service create these test environments for the developer, and when they're done, they can on-demand deprovision and clean up those objects. The wider outer loop addresses when database changes are needed as part of that sprint. It starts out the same way. We have the on-demand self-service provisioning being delivered by the tooling in your organization. But now the developer has expanded authority upon those set of database objects in a fenced manner, and they can make the modifications directly right when they need them to be made in their sprint. Now, that work may follow the same path of deprovisioning if you conform to the idea that fail fast is a good thing. Let's discover things quickly that don't work. We can deprovision them, reprovision a fresh set, and maybe adjust our design and move forward, identifying those things as quickly as possible. But also, some of those changes, and hopefully most of them, are helping us advance innovations to production more quickly, making our companies more competitive. And that's the upper part of the loop. While the developer can change their provision sandbox environment on their own, they can't check it back into the master branch or the source schema. This requires approval. And this is where the tooling should help collaborate between the developer and the administrator, whether that's DBA, the data architect, all 3, so that those changes can be properly vetted. Maybe there needs to be some iteration that takes place in that approval cycle. And when all agree that the tooling then merges those changes into the source environment, it can then be promoted across the needed landscapes and into production. We will come back to that idea in a later slide. Database as code is the third major tenet, and this falls more into the camp of helping to liberate the administrator. The idea that we're very used to tracking our application source code under source code management and with version control. Why can't that apply to our database objects? And it can. In the case of DB2 or many relational databases, it can be the DDL. That's the code that we can use checked into a source code manager, and those objects are now tracked under source code management. It unites your application version control and infrastructure as code. This is the part of the database as a service delivery to your organization that helps extend infrastructure as code down to the database level. You may work with or have heard of products like Chef, Puppet, Ansible, SaltStack. I'm sure there are others where, for example, in the case of Chef, you've got a recipe that can spin up a virtual environment for a developer or a team by reading the recipe and virtually creating something from the OS up. That can also be done for your data sources. Our recipe, in this case, is the DDL, properly packaged. We'll talk more about the packaging of that DDL shortly. So that on demand and self-service, the developer can check out a branch of the source code objects that they need. They're created for them automatically. Maybe they just test, maybe they modify, and when they modify them, the approval cycle kicks in to merge it back into the master branch. So database as code is our third major tenet. And then the fourth major tenet is having the proper management across this to make administrators comfortable. System administrators, database administrators, data architects, etc. There's a lot of metadata that governs operations here, from adopting objects under DevOps control. You may want to start small and grow. You want to have tooling that helps support that by setting up perhaps separate environments where different teams or users can perform provisioning and DevOps activities, monitoring those, setting limits on those, reporting on storage, understanding which users have which authority to which objects. And I don't mean in the database security scheme itself, but for DevOps purposes. All very important rules that, to make an administrator comfortable, the tooling engine should be watching for these rules all the time. And that includes things like what we refer to as site rules. And site rules are basically codifying things like your naming standards, your placement standards, etc., so that as the developers performing their modification activities against database objects, the proper guide rails are in place so that they can't go off the road. With enterprise servers like a System Z environment where DB2 for ZOS resides, these are typically shared environments. So it's natural for customers to want to be able to control but perform these activities in a shared environment, as compared to perhaps what might be happen in a distributed environment. An entire OS on up might be provisioned for the developer. That can happen for ZOS as well. For example, with a tool like ZD&T, where we're emulating the ZOS environment on a Linux server. That can happen. It could be possible to spin up an actual ZVM LPAR, although in the customers we're talking to, that seems less likely. Most of the time, it's happening in a shared environment, so the tooling has to help manage this and control it so that we can, again, keep the platform relevant. So what are some of the important points there? One is the ability to register participating DB2s and DB2 objects, both where we discover these objects to adopt them into DevOps control, and also DB2 environments where provisioning activities are allowed to take place and are properly monitored. Where provisioning activities are taking place, developers are given expanded authorities, and you'll want your tooling to monitor that and handle that automatically for you and fence it properly so that the developer has free rein to operate within their sprint, but that when the merging of that change is necessary, or should they go outside their sandbox, that those same authorities aren't there for the developer. It's fenced within their provisioning environments. A key component of this in a shared environment is namespace management, primarily the database and the schema creator, that allow multiple instances to exist at any one point in time and not have one developer stepping on another. You want that flexibility, though, to decide what is the best implementation for your shop. As we just discussed, things like site rules for naming, placement, definition, that the tooling's watching out for your best interest all the time. Perhaps you want the storage monitored and reported, and then that it's easy to view these rules and metrics so that you can take a look at how effective your DevOps adoption down to the database level is within your shop. Tools tend to fall into one of two camps. It doesn't mean that they might not have elements of both, but if you dig deep enough, you'll probably see that one of the two camps is the primary definition of the tool: state-based versus migration-based approaches. To net it out, a state-based approach, the tooling determines the differences between your source DDL and your modified DDL and constructs the upgrade path automatically for you. It's likely you want this to be reported to you first as well so that you can tell, well, what is the plan? Is that acceptable to me? Especially early on as you're getting used to the tool. But then when you approve of that plan can move forward and merge in the changes that perhaps a developer has made. That's kind of at the heart of a state-based approach. Where a migration-based approach, a series of modification scripts are written and stored in Git and sequenced that allow you to migrate a database schema from one state to the next. This can be very useful for very complex style migrations. But if we go back to, we're really trying to elevate the developer and allow them to perform single piece flow according to lean principles, that they can get as much of their work done as possible on their own, self-service on demand. The developers got enough to deal with in terms of getting those features into production and being experts in their programming languages. The database domain is not necessarily their expertise. That's not to say there aren't some very database savvy developers out there, but that's why database administrators are so important to the enterprise. So the developer is not necessarily the best role to be creating database scripts that alter a schema from one state to the next. And that's why I tend to prefer the state-based approach, where the tool itself has the expert analysis and compare capabilities and builds the update script for you and can also implement it for you. But again, there's pros and cons to each. Let's take a look at some of the workflows to kind of pull things together. If you look way to the left, there's going to be some setup that needs to be done. The tooling needs to understand what subsystems are participating under DevOps control, which subsystems are potential targets for our provisioning operations. The tooling will need to know information about the users that have access to the tool and how they reside in different teams, which could be one or many teams in your organization. And then you define the site rules, and the limits and the storage thresholds, all the management capabilities within the tool so that the tool is watching out for your best interests. The first step is adopting objects under DevOps control. And I'm showing that here through a container or an envelope called an application. But I'm not talking about application code here. I'm talking about the database objects that need to naturally be created together in order to sufficiently support an application in test and development. An administrator would likely set this up in advance, though by defining these objects into this container that I'm referring to as an application, they're now under DevOps control. And the language, in DB2's case, DDL, can then be checked into Git in the master branch, now tracking these objects under source code control and version management from that point forward. Once we have that definition in place, it's very easy for our development community to get the right database objects for the sprint that they're working on. And there may be 0, 1, or many instances created at any point in time through the on-demand self-service provisioning that the tool provides. These can become user branches off of your Git master branch so that we, again, can track the activity through source code control, source code management. As we discussed earlier with the inner loop, some of those instances will just be there for testing purposes. And maybe the developer discovers early that that particular design needs to be tweaked somewhat. So deprovisioning should be supported by the tool to completely clean up that footprint, that sandbox footprint, and including any dependent objects. For example, maybe some applications were bound and dependent packages were created, to find those and make sure that we're keeping our shared environments clean. But if we consider the outer loop, some of those instances will be modified. And here we show a change of a column on one of our tables. That happens immediately on demand for the developer. They can immediately test that particular change, maybe make some additional changes. And if they determine that they've met the requirements of their sprint, the acceptance criteria is met, then they likely want that to be propagated throughout our landscapes and into production. They don't have the authority to make these changes outside of their sandbox. So by taking the Git methodology a step further, We have the developer issue a pull request, which invokes the approval cycle, allowing an administrator to see there is some work to be reviewed. We want to make that easy as well, and this is where things like source code managers like Git can be very helpful because we can drive diff commands between the previous commit point and the current commit point and show the administrator exactly what's been changed, how it will in fact impact the source and the DB2 that's kept in sync with the master branch if it's accepted. And so this approval process needs to allow for iteration. We may need to comment as an administrator, we may need to comment and send it back to the developer and iterate with them with the intent of moving this forward and again, supporting the fast release cycle. So eventually we get to the approval cycle, and this is where the tooling should determine the proper implementation plan to merge that change back into the source environment. Again, this is updating the master branch within Git, but also the source DB2 from which that branch was discovered. There could be many objects that get changed as part of the source merge activity. At that point in time, the instance on the bottom right is now back leveled. That developer might have their own changes that they're making, but they don't have the change of the instance that's at the top of the column. So this is where our tooling should understand the scope of the provisioning activity that's taken place and make sure we notify the developer that they're back leveled and they need to accept those changes from the source before they move forward with their own changes so that we're always driving towards schema synchronization. There are many open source and commercial pipelines available. They help orchestrate your workflows. They can perform operations much like your scheduler does today to orchestrate job streams. There's many methods, but they might be issuing REST calls. They might be driving shell scripts or perhaps using templates that are vendor or perhaps provided by your own development teams that have baked together a set of steps that need to take place. And you might have database as a service templates. The different pipeline tools have different scripting languages. For example, with Jenkins and some of the pipeline work that I've done for customers, that's been written in Groovy, which is a derivative of Java. I believe Ansible is very Python based. So you might find different languages based on the tool that you're working with for infrastructure as service or CI/CD. But the bottom line is, it seems like everything is being delivered as code today, and that applies to pipelines as well. To manage our pipelines under source code management and version control, we need to have pipelines as code. And certainly Jenkins allows that through its Groovy language, and the others do through their own scripting language as well. So we now can manage this code just like we manage our application code. What are some of the things we need to consider when composing pipelines? And this is generic, but it was put together with the idea of supporting database as a service. One is metadata management. Whatever tool you're working with, or perhaps whatever you develop on your own, it's likely you need to store some metadata about the configuration and the operation of that particular tool. What are my sources? What are my targets? Who owns what objects? Are edits allowed, etc. So dig into that. What metadata is supported by your tool of choice or the tool you intend to develop? And go back in the presentation to the 4 pillars and some of the major tenets and make sure that they're all represented in that metadata somewhere. When it comes to the APIs themselves, you'll find they tend to fall into the synchronous or the asynchronous camp. And you'll want to understand this up front. So at the bottom of the slide, you see a bullet titled Getting Started. And one of the things listed down there is check the documentation for your APIs, and Swagger is noted down there. If you've not yet worked with Swagger, it's probably one of the more popular tools, open source, to document REST APIs. That's where we document all of our REST APIs. And this is where you can learn about the response for this particular API. What are its inputs? What are its outputs? And is this being performed synchronous or asynchronously? If you're a DB2 person, you might liken your REST API to something similar to a routine or a store procedure. If you were to invoke a store procedure, you'd want to research it, maybe look at the metadata about it, understand its inputs and its outputs, and how it's going to work within a particular application construct. Same thing here. But when it comes to the REST APIs, it's important to understand when you get a response back, is that API actually done? Or could there be more work taking place in the background? Could it be asynchronous? Most GET APIs, at least that I've come across, are synchronous in nature. When the API responds back and gives you a return code and perhaps delivers a JSON body back to you, the API has been completed. But modification APIs like post or put or delete, or maybe patch, which is not shown on this chart, they may or may not be synchronous. Some of these may be asynchronous. In other words, it's more like fire and forget. the the API may tell you it worked, but what that really means in an asynchronous setting is you presented to the server a valid API request and it's been accepted. But there could be batch activity taking place to actually satisfy that particular request. So this leads into the third point, which is if you know you're working with an asynchronous API, you likely need to invoke some kind of polling in your automation or in your script to determine if that background activity has taken place, especially if you have a sequence of activities that are dependent upon one another, like the bubble chart shown on the left here. That polling will likely be a GET API, that returns the resource that you've just created or updated or perhaps deleted through the post, put, delete, patch verbs. So that might be perhaps a loop that you run, every few seconds or configurable number of seconds. And when you see that activity is completed within a GET call, you move on then to your next step. For the metadata specifically with database as a service, I believe one of the things you want to check for is that it's set up to allow you to adopt at your pace. In other words, you don't want to boil the ocean. That can be too much to bite off. DevOps is big enough itself, but if you carve out the foothold of I'm going to implement database as a service in my shop, you don't want to have to implement this for all your DB2 objects all at once. That's too big. So you want to make sure that your tooling or your designs are set up to allow you to adopt objects under DevOps control at the proper speed for your organization. Database as a service object definitions, you want to be able to query this metadata now and determine what is available for provisioning activities. How is it being used? Um, are there constructs are they easy to understand for a developer and to consume? So this is where perhaps we get into some of our rules. If a rule is violated, let's say we have a naming rule, a column or a table naming rule, can we, one, tell the developer that they perhaps aren't conforming to our naming standard early, but also communicate appropriately to them so it's easy to understand how they violated the rule and they can hopefully fix it on their own. Ownership and editability is pretty important because just because we're supporting a fast release cycle doesn't mean we don't have to have integrity in the edits that take place to our database objects. This is where things like understanding the users and how they're appropriately grouped into teams, in which teams own the application objects, fall into play. You'd likely want that structure within your tooling. We've talked about the approval cycle. While we want to elevate the developer to single piece flow, be able to complete their work, and they have expanded authority to do that within their sandbox, our integrated environments are hardened and protected for a reason. And to protect those environments before that change makes its way out of integration and into our integrated landscapes, this is where the approval cycle comes in. So it should be easy for an administrator to quickly come up to speed on what did the developer do, and therefore be able to make a quick determination if this can be approved, or if they need to iterate with the developer on those changes. And then lastly, looking at the metadata, does it have the proper definitions for monitoring and usage to provide control for your administrators, but also perhaps to drive into DevOps or database as a service operational analytics. Drawing to a close here, we took a quick look at the importance behind why database as a service could be critical for your enterprise. It really drives back to your overall business being competitive in the market space by putting efficiency into action and really implementing some of the lean and agile methods that have been in our application development environments for a long time. I hope you found this session helpful in calling out some of these non-product specific attributes of database as a service and key considerations for you to use in your evaluation or perhaps even your own creation of a homegrown database as a service engine that could help drive these processes within your automation in your shop. If you'd like to explore these further or expand on any of these ideas, feel free to reach out to me. My name again is on the title and my email is on the title slide of this presentation. Or perhaps just consider this presentation a checklist or a conversation for you to use as you evaluate your vendor of choice. Thank you for attending this presentation and this session. I believe we're going to have time for some questions now, but if you're on to your next session or listening to this as a replay, enjoy the remainder of your Data Summit experience. Please remember to complete any session evaluations that may be sent your way. Regards to you. Please stay safe and good day.
Thank you, Paul. I would point out to everybody that the slide deck is under Files, which is underneath the description of this session. So we do have his complete slide deck just waiting for you. So when he says, yeah, you want to take a look at that checklist, you've got the files, you can do that. So we do have a question here for you, Paul, and for the rest of you, feel free to put your questions into the chat box there in Feedloop. So question, I've heard your best practice ideas, good. How might I get started? So what would you recommend as the best starting point here?
Sure, that's a good question. In fact, it gives me the opportunity to mention something you just mentioned, Mary D, that
Yes.
the slide deck is posted. And in fact, there's more material in what I posted than what I just presented, so that I didn't go too much into the weeds here. But I would point you to slide 13 in that particular deck, because it's an architecture slide that gives a depiction of what your existing, maybe legacy landscapes might look like, and how you can either augment them or, in some cases, maybe add additional landscapes to that architecture to fulfill a CI/CD role for database as a service. Just a quick example, I was working with a rather large insurance company about 2, maybe 3 months ago, and I took that architecture chart and we kind of virtually superimposed it over their existing landscapes. And we were able to rather quickly see they had most of that in place already. We just needed to assign some additional roles to some of their servers, to some of the landscapes within their organization. So that's one consideration from an overall landscape or architecture perspective. Another way to look at that might be, you might have to do some self-assessment of where are you in your DevOps maturity, in your DevOps journey. Are you still focused on what your source code manager should be for the future? Is your automation all in place? Are you still looking at tooling there? Maybe you're already addressing database as a service. Maybe you're not. So some ideas there could be, I'm guessing you've got vendors of choice that you like to work with, and see if they can help you. See if they can work with you in a consulting style fashion to maybe extend how you're using the products you have today, or maybe they offer some additional capabilities there. Whether it's consultation through your existing vendors or maybe some third-party consultants, I think you can bring in that knowledge and help you figure out, where's my foothold? Where can I get started? Because the last thing you want to do is attempt to boil the ocean with this. It will slow you down. This is the perfect analysis paralysis example, and you don't want to end up there.
Ah, yes, analysis paralysis. I think I've heard that before somewhere.
I bet you have.
We do have another question here. Can these practices that you described here apply to large monolithic applications?
Another topic that I think would be great to dig into, but what I'll mention is clearly an application that is more loosely coupled is a more natural fit to move into a fast release cycle. A large monolithic application can be more challenging. This is where tooling can help, though, quite a bit. Now, there's the whole process and culture side of DevOps as well. And if you're not ready to adopt a change in the way you operate for a faster release cycle, that can be more challenging than the application itself. But what I highly recommend for large monolithic applications, and it can be done through tooling, is to take a very normalized approach, an approach similar to how you would design your databases. And most often inside that large monolithic application, you have multiple functions. Can we identify a somewhat of a microcosm or several microcosms that are within that application, and see if we can carve that out into smaller containers so that we can, again, parallel and fit alongside the developer sprint. It takes work. It may not be a slam dunk, but again, I think your consultants or your vendor through consulting could help you with that.
So what you're saying is, with a monolithic application, you want to think of it not as monolithic, but as smaller components.
As much as possible. And there'll always be, yeah, but it's so integrated, it all works together. Absolutely. And when you start to pull the thread on a drape, sometimes the whole panel comes off. So this is where the work comes in, right? And that's why I tend to look at it from a data perspective. You can't ignore the process, but I start with the data perspective. Can we normalize that down into smaller components, micro components? And then let's get to the processes. Some of the processes may negate the normalization work, but at least that's a good start. Let's get a map, and then let's start to check out the territory and see if we can make that more manageable. It is more challenging in a monolith, but it's not undoable.
You know, I think it's interesting that you just mentioned culture, because that has come up in a couple of other presentations over the last 2 days. And I think it's a word that is often misinterpreted. Some people, you say culture, and some people hear one thing and some people say another. And I think the way you're using it is in terms of organizational culture. I could be completely wrong here.
You're not wrong. I've worked in databases, in particular databases with enterprises, for 35 years, and I've had different roles. As a vendor for about half my career, we've been very focused and successful working with the administrator audience, not to ignore the developer side. They're important, and we want to understand their requirements, but we can sell a database tool by talking to administrators. That's not true here. We have to work across organizational boundaries, and it's more difficult if someone at the grassroots level says, hey, I think this is a good thing. Let's implement database as a service and build these efficiencies into our organization. When it's a top-down cultural edict that we're in some cases, this may sound dramatic, but in some cases, companies are in a fight for their life against competitors they didn't even see coming out of left
Yeah.
field. And these edicts come down that we have to become more competitive. We have to restructure our processes. That's a different approach, top down than bottoms up.
Sure.
Bottoms up is harder in the DevOps world from my perspective, and we have to work cross teams much more. It's much more important to work across organizational teams.
Thank you. That was great. Really, really solid information that you've given us there, Paul. That's much appreciated. So thank you for the presentation. Thank you for answering all the questions.
Thank you
And
for this time.
yeah, and if people have other questions that they'd like to pose to Paul, we can now move over to the networking area on FeedLoop platform. And we are track C. So thank you again to Paul.
Thank you. Bye, everybody.